Hello, how are you? I would like to finish the unit of trigonometry today, for we have already learned all of the concepts and laws. So, today, we are going to start with a review of the content we have learned, and we will end with a couple of example problems that are more complex than before. The first part of trigonometry is the definition of the trigonometric ratios. We learned three of them: sine, cosine, and tan. They are defined in right triangles. Okay, in the right triangle, sine theta, sine this angle, sine theta, is defined as opposite over hypotenuse. Cosine this angle is equal to adjacent over hypotenuse. And tan this angle is defined as opposite over adjacent. Okay. So sine A is equal to, or sine theta is equal to opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. Tangent theta is equal to opposite over adjacent. Although these trigonometric ratios are defined in right triangles, the value of the sine, or all the trigonometric ratios, the value of the sine is determined by the amount of the angle. Okay, so for example, sine 30 degrees is equal to 0.5. Sine 45 degrees is equal to 0.707. And sine 60 degrees is equal to 0.866. Cosine, the value of cosine is also determined, is also decided by the amount of the angle. Okay, so the value of cosine is determined by the amount of the angle. For example, cosine 30 degree is equal to 0.866. Cosine 45 degrees is equal to 0.707. And cosine 60 degrees is equal to 0.5. So, although the trigonometric ratios are defined in right triangles, but they can be used out of the right triangles, right? Okay, so they can be used in the sine law. So the second part of this trigonometric ratio is the sine law. Okay, this is the sine law. So what is the sine law? The sine law is that in a given triangle, sine A is equal to sine A over sine A is equal to B over sine B, and this is also equal to C over sine C. All these fractions can be simultaneously flipped. If they are all simultaneously flipped, then it is this: sine A over A is equal to sine B over B. This is also equal to sine C over C. Okay, so both this and this are the sine law. This is the sine law, so this is also sine law, right? Okay, so this is the sine law. All the any randomly given triangles obey the sine law. So all triangles obey the sine law. A right triangle also obeys the sine law. But if you see a right triangle, then it's not necessary to use the sine law, right? It is reduced into the definition of the trigonometric ratio of sine. So you use the definition of sine. You do not use the sine law. Why? Because using sine law will waste more of your time, right? So you should avoid using sine law when this is a right triangle. If you meet with a right triangle, then the Pythagorean theorem comes to your mind first, right? And then the definition of the trigonometric ratios come to your mind. Okay. If you see a right triangle, do not use the sine law because it wastes too much of your time. And then the cosine law. This is the cosine law, right? Cosine law looks scary. However, it's not scary at all, right? Because this first part of the cosine law, is a Pythagorean theorem. Because you studied Pythagorean theorem before, so you know you are very familiar with the Pythagorean theory. So you first write down the Pythagorean theorem and then minus a tail, right? So this is a tail of the Pythagorean theorem. So you added a tail to the Pythagorean theorem, then it is the cosine law. So cosine law is c squared is equal to a squared plus b squared minus 2ab cosine c. So you read this many times and you can remember it. After you have remembered this, then with your memory, you are able to write down. The other forms of the cosine law, right? This cosine law is equivalent to that. It is also equivalent to this. Okay, so all these three equations are cosine law, right? And it's not necessary for you to memorize all of them. You remember only one of them, then it is enough, right? Okay, c squared is equal to b squared plus a squared plus b squared minus 2ab cosine c. Okay, so this is cosine law. Okay, and then we come to the second part of our today's work. Okay, let's take a look at a couple of example problems that are more complex than before. Okay, this is more complex than before, right? Because this diagram is made up of two composite triangles. So these two triangles make a composite diagram. Okay, so it is more complex. And then let's read this question. What is it? A weather balloon is directly between two tracking stations. Okay, so first you draw the on the ground. Okay, you find two tracking stations and you name them A and B. And the balloon is of course in the sky, right? It is in the sky, so it is above the ground. It is above the ground, and it is between the two tracking stations, right? Okay, so it is between these two tracking stations, and then you name this point. This point is named C. Okay, so A, B, C make a triangle, right? So it makes a triangle. And the angles of elevation from the two tracking stations are 55 degrees and 68 degrees. So the angle of elevation, so this is a angle of elevation because it is above the ground, right? Because it is above the ground, so it is called angle of elevation. Okay, so this angle of elevation is 55 degrees, and that one is A is 68 degrees. You can assign 68 to here and 55 to there. Okay, it doesn't matter. Okay, if you assign you reverse the positions of these two numbers. Okay, it doesn't matter. But naturally, we first assign 55 to here, and then 68 to the second one, right? Okay. If the tracking stations are 20 kilometers apart, okay, they are 20 kilometers apart. Okay, so the length is 20 km. Okay. Determine the altitude of the weather balloon. Okay, determine the altitude. The altitude is the height. Okay. This word altitude means the height, right? So the height is a vertical line, right? Or say a perpendicular line to the base. Okay, a perpendicular line to the base with the base. Okay. In this situation, because the base is on the horizontal line, and then the height is the vertical line. Okay. And we name this height h. Okay, small h, lowercase h. Okay, the height. And then we take a look at this diagram. What information do we have? Okay, we have such information: this angle and this angle. Okay, so in this triangle, we have already got two. We have already got two angles. Okay. So we instinctively we know the third one, right? Because the total internal angles is equal to 180 degrees. So with 180 degree, we are able to find this angle. Okay. So this angle C, or we call it angle ACB, because angle C is confusing. It can mean this angle. It can also mean this angle. It can also mean the total entire angle, right? Okay, so this angle C is confusing. And then if you want to be clear, and then you use this method ACB. Okay, so use three capital letters to name a angle. Okay, angle ACB. You can also call it angle BCA because they mean the same. The only requirement is that the vertex C, the letter C, should be in the middle of the three letters. Okay, so angle ACB, angle ACB. Okay, so it means this entire angle. Okay, so angle ACB is equal to 180 minus 55 minus 68. So the result is 57, right? So this angle is equal to 57 degrees. Okay, so now we have already known three angles, all the angles of this big triangle. And we also know a side, right? We also know a side. So with three angles and a side, of course we can use sine law to find any other side, right? Or say both the other two sides. Okay, this side and this side. But this side, we use just one side, then it's enough, right? So we use one side. So for example, we choose this side, and we name it x. So we name the length of this side x. Okay, and then we use sine law. So x over sine 68 is equal to 20 over sine 57, right? And then we write down the equation, or say the sine law. Okay, so x over sine 68 is equal to 20 over sine 57, and there is only one unknown. So let's solve this equation. Bring this bottom to the right side. Okay, so x is equal to sine 68 multiplied by the whole thing of the original right side. Okay, and then with your calculator you are able to get x. The x is equal to 22.1. Okay, so we have got this length, right? It's not necessary to get this length if we have already got this. Okay, so now in this smaller triangle, let's take a look. What is it? It is a right triangle, right? This is a right triangle. In this right triangle, we have already known one angle and a right angle. So in right triangle, what comes to our mind first? The trigonometric ratios, right? Because we have already seen an angle here. Okay, so the trigonometric ratios comes to our mind. So what is it? Which ratio do we use? Because for this 55 degrees, the h is opposite. This is opposite side, right? And the x is the hypotenuse. Okay, so the opposite and the hypotenuse are involved, and then sine, right? Sine comes to our mind. Okay, so sine angle A is equal to h over x. Okay, so h over x. Because the x we have already known, so x is 22.1. So x is 22.1, and the a we also know it, so it is sine 55 degrees. Okay, only h is not known yet. Okay, so we solve this equation by moving this 22.1 to the left side. Okay, we get this part. Okay, so this is what we got. And this is equal to h. H is left behind on the right hand side, right? Okay. And with your calculator, please bring out your calculator, and then you get this h is equal to this. This is 18.1, right? So we have got the h. This h is the height, and this height is what we are looking for. Okay, the altitude. It is the altitude. Okay, we have got it. Okay, it is 18.1. What is the unit? The unit is km, right? Km, kilometer. So finally we don't forget to answer. Okay, so answer. The altitude of the weather balloon is about 18 kilometers. Okay, so this problem is solved. Let's take a look at another one. Okay, we are familiar with such a situation, right? We saw this before. Okay, this is a cliff. Okay, this is a river. So below the cliff there is a river, and you don't have to climb this cliff. You don't have to cross the river. You just stay on this bank, and you measure 2 points. Measure the distance, and you also measure. You pick a point here as the aim of your eyesight, and also pick another vertically go up with your eyesight to a point here, and then you measure the angle of elevation, and you also measure such a triangle. In such a triangle you measure these two angles, and then you are able to calculate. You are able to figure out the height of this cliff. Okay, so the problem here is the requirement here is find the height of the cliff shown in the diagram. Okay, and the requirement is to the nearest meter. Okay, to the nearest meter. We see here there are two triangles, right? So this is more complex than before. Okay, so this is a complex problem. Let's take a closer look at these two triangles. Which triangle gives more information? Of course, this one, right? This one lying on the ground. This one lying on the ground. It gives us more information because the two angles are given, and then that angle we instinctively we can get it. So this angle we use the 180, right? Use 180 to minus this and that, so we get that one. And let's do it. So this angle we give it a name because we need to write it here, right? We want to write it here, then we need to give it a name. But because if you use B as the name, then it can cause confusion, right? Some people may be confused. So you use 3 letters to stand for it. Okay, so angle CBD. Okay, angle CBD is equal to 180 minus 20. Minus 62. Minus this 62, and then minus 50. Minus this 50, and then we get that one. Okay, and easily we can get it, right? So it is 68. So this angle is 68 degrees. It looks like a obtuse angle, right? It looks like a angle greater than 90 degrees. However, it is because this triangle is lying here, because it lies here, so it looks big. However, this angle is not greater than 90 degrees, right? It is much smaller than 90 degrees. Okay, it is 68 degrees, this one. So we have to rely on our calculation, right? We should not just rely on our eyesight, because our vision may not be 100% accurate. Okay. So we have got the 3 angles of this triangle, and we also know one side. Okay, so we know this side, and then sine law comes to our mind, right? So we use sine law. Okay. Okay, so use sine law to find what? Use sine law to find what? Use sine law because you have already known 3 angles, and you also know this side. So use sine law, you can either find this side or that one. But if you find this side, it's useless, right? Because this side is not related to that triangle. Only this BC, this side is the common side, right? It is shared by these 2 triangles. So if we find this CB or BC, we find this shared common side, then we can come to, or say our attention can be shifted to this triangle, right? So logically we are able to find that length, right? So the better thing is to find this first. Okay, let's find this length. Okay, so this length BC over sine 50, right? BC over sine 50 is equal to 160 over sine 68, right? This is 68. So we write it down. BC, yeah, BC over sine 50, yeah, over sine 50 is equal to 160, yeah, 160 over sine 68, yeah, sine 68. Okay, so we have established a equation. Then let's solve it. Let's solve it by moving this bottom to the right hand side. So BC is equal to this right side multiplied by sine 50. Okay, so now borrowing out your calculator. So on your calculator you can get BC is equal to 132, right? So 132, and this is rounded to the nearest meter, right? Because the unit here is a meter. Okay, so we have got this shared common side. Now let's shift our attention to this standing triangle. This standing triangle is a right triangle, right? Because this is a right triangle, so we refrain from thinking about sine law, cosine law, right? So we should think about the trigonometric ratios, right? So which ratio shall we use? Because the cliff is the opposite of this 33, right? So for this angle of 33, the cliff is the opposite, and the river is the adjacent. We have already got this river, the width of this river. Okay, so it is the opposite over adjacent, so it is tangent, right? So we write the ratio of tangent. So tan 33, tan 33 is equal to, okay, this we name it AB, right? So AB, this letter, this end point, and this end point. So use the length between the two end points is AB. Okay, so AB over this length is 132, right? So 132. Okay, tangent tan 33 is equal to AB over 132. So okay, and then let's solve this equation. AB is equal to what? You move this 132 to the left side, so it is 132 multiplied by tan 33, and then this is equal to AB. Calculator, please, calculator. So AB is equal to 86, right? It is rounded to the nearest meter. Okay, so finally we answer. The answer is the height of the cliff is about 86 meters. Okay, it is 86 meters. Then we solved a complex problem, right? So the final question is when to use sine law, when to use cosine law, right? When the triangle, a random triangle, which is not a right triangle, if this is not a right triangle, is given to you, and in this triangle, you know side angle, right? SA, then you use sine law to find a second angle. Okay, and if you are given two angles, then instinctively you can find the third angle, right? So with three angles and one side, you are able to use sine law to find a second side, right? This is the same thing. Okay, you have already known two angles, so the third angle is also known. Okay, with three angles and one side, you are able to use sine law to find a second side, either this one or that one. Okay, so sine law to find a side. And if you are given SAS, then use cosine law to find the third side, right? And if you are given three sides, then you use cosine law to find a angle, right? To find a angle, and then use sine law to find a second angle, and then use 180 to find the third angle. Okay, so this is the application of the sine law and the cosine law. How about the trigonometric ratios? Okay, when you see a right triangle, then use the definition of the trigonometric ratios, right? Okay, so this is our today's work. Okay, thank you, bye.